Let us discuss carbonyl compounds. In the carbonyl compounds, chemical properties of carbonyl compounds. First, one reaction we have seen. Carbonyl compounds react with aldehyde, react with alcohol. Carbonyl compounds react with alcohol in the presence of dry HCl to give acetal. Acetal on hydrolysis gives back carbonyl compound. Okay, where we can use this reaction, where we can use this type of reaction, that we will see. Okay, now we will take the compound. Here ketone is there. Here COOET, that is ester is present. It is ester, it is ketone. This we have to take for reduction. In what way? In the sense, ketone should not be undergoing reduction. Ester alone we have to make it to undergo reduction. Ester should go for reduction. Okay, ketone should not go for reduction. Like this we have to do it. Sir, how to do this one? Here ester is undergoing reduction. Ketone should not undergo reduction. But actually what will happen in the sense, ketone ester both will undergo reduction. Suppose if you take reducing agent, lithium aluminum hydride, reducing agent, if you take, this reduces both keto, this carbonyl group and ester group. Carbonyl group will undergo reduction, ester group also will undergo reduction in the presence of reducing agent lithium aluminum hydride. But what we want to do in the sense, we want to make ester to undergo reduction, ketone not. Ketone should not undergo reduction. Ester alone should undergo reduction. So what to do? Let us protect keto group not to attack by reducing agent. Okay. How to protect this keto group? By acetal formation. By acetal formation. Okay. So first we will protect this keto group against reducing agent. So we will take this for acetal formation first. It is ketone. This we will take for acetal. This ketone is treated with diol in the presence of what? In the sense of dry HCl gas. In the presence of dry HCl gas. What happens means ketone is protected. Ketone is becoming acetal. Ketone is becoming acetal. Okay. Ketone becomes acetal, we can say. So ketone has become acetal. This is called what in the sense? Cyclic ketol. Cyclic ketol. Now we will add a reducing agent. Now we are adding reducing agent lithium aluminum hydride. Solvent is ether. So we have added a reducing agent and solvent we added. So what happens means this ester undergoes reduction. This ester undergoes reduction. But this acetal is not undergoing reduction. Acetal is not undergoing reduction. Ester on reduction gives what in the sense? This CO part. This CO part becomes CH2H. That is how reduction possible means like this. The CO part becomes CH2H. This is ethanol. Ethanol will be removed. Ethanol will be formed. Okay. Next, this is taken for acidic hydrolysis. Acidic hydrolysis. Acidic hydrolysis means this acetal, this ketol, this cyclic ketol again becomes ketone. This cyclic ketol again becomes ketone. Therefore, we can write here double bond. Okay, this cyclic ketol again becomes ketone, we can say. So cyclic ketol has become ketone. Therefore, here if you see ester has gone for reduction, ketone has not gone for reduction. Actually, this reducing agent, lithium aluminum hydride, reduces ketone as well as ester. But we made ester alone to undergo reduction, but not ketone. How? We converted ketone into ketol form. This ketol is not going for reduction with the lithium aluminum hydride. Okay. So this acetal or ketol, this ketol protects this carbonyl group against alkaline oxidants. Okay, and then next point we will see acetal. Acetal protects aldehyde group. Aldehyde group means carbonyl group, like this we can say. Aldehyde group against alkaline alkaline oxidants. Alkaline oxidants. Okay, alkaline oxidants. Alkaline oxidants. Here reducing agent we said, here oxidizing agent we said. Acetal protects aldehyde group against alkaline oxidants. That means this oxidizing agent will not oxidize aldehyde group if you convert this into acetal form. Okay, so aldehyde will not undergo oxidation in the presence of alkaline oxidizing agent when you convert aldehyde into acetal. Okay, so how reducing agent is not affecting this acetal, like this oxidizing alkaline oxidizing agent also is not affecting acetal. Okay, therefore aldehyde group will be protected. Okay, therefore this acetal formation or ketol formation is used for what, in the sense protecting carbonyl group. Okay, therefore in this case ketone is there, ester is there. Ester should undergo reduction, ketone should not undergo reduction. Okay, so what shall we do? We are converting ketone into ketone, cyclic ketone. Then reducing agent we are adding. Reducing agent reduces ester but not ketone, but reducing agent reduce ketone. So here ketone is not there, but we have converted ketone in the form of cyclic ketone. Cyclic ketone will not undergo reduction with the lithium aluminum hydride. Therefore cyclic ketone will be as it is, only ester undergoing reduction and gives primary alcohol. This on acidic hydrolysis, cyclic ketone again gives the ketone. Okay, like this acetal formation is protecting aldehyde group against alkaline oxidizing agent. That means convert aldehyde into acetal, then add alkaline oxidizing agent. This acetal will not undergo any reaction, therefore aldehyde group is protected. Otherwise aldehyde group easily undergoes oxidation, sir. So far what we have discussed, in the sense nucleophilic addition we have discussed. So far, we have discussed what reactions, in the sense nucleophilic addition reactions we have discussed. Now, what is the order of reactivity towards nucleophilic addition reaction we have to see. Okay. Now we will take formaldehyde and aliphatic aldehyde we will take. Aliphatic aldehyde, which can undergo nucleophilic addition easily. Which can undergo nucleophilic addition easily, that we will see. Okay. So formaldehyde we are taking like this. Other aldehyde will take like this. Other aliphatic aldehyde we have taken. Okay, now we will give form positive. Here partial positive charge, partial negative charge. Here also partial positive charge, partial negative charge. Nucleophile will attack this. Okay, nucleophile is attacking this one. This carbon is the electrophilic center. This carbon is the electrophilic center. Now, this R group shows plus I effect. This R group shows plus I effect. Due to plus I effect in the sense this R group is donating sigma electron cloud. This R group is donating sigma electron cloud. This R group is donating sigma electron cloud to this carbon. Therefore, this carbon is getting some electron cloud from this R group. Therefore, here electron density becomes high. Therefore, this electrophilic nature becomes low. But here electrophilic nature is high. Here electrophilic nature is high. Here electrophilic nature is low. So nucleophile attacks easily, whereas less. Therefore, formaldehyde undergoes nucleophilic addition to higher tendency when compared to aliphatic aldehyde. Then we will take aromatic aldehyde. We will take aromatic aldehyde. In aromatic aldehyde, how it will be there, that we will see. Aromatic aldehyde. Aromatic aldehyde in the sense like this. Aromatic aldehyde in the sense like this we can say. Okay. So in the aromatic aldehyde also, what we can say in the sense, here this carbon is having partial positive charge, oxygen is having partial negative charge, because oxygen is more electronegative than carbon. But what happens means here resonance is possible. This pi bond is moving here, this pi bond is coming here. Due to resonance, this carbon is getting electron cloud from this phenyl ring. This carbon is getting electron cloud from this phenyl ring. Therefore, here positive charge is less, here positive charge is more. Therefore, here positive charge is less means electrophilic nature is less, electrophilic nature is more. So nucleophile attacks easily, nucleophile attacks less easily. Therefore, aliphatic aldehyde nucleophilic addition is more than aromatic aldehyde. Okay, aromatic aldehyde. Next, we will take a aliphatic ketone. We will take We are taking aliphatic ketone. So what is the nucleophilic addition here? Aliphatic ketone in the sense, ketone we will write like this. Okay, ketone we have written like this. In the ketone we can say that this is partial positive charge, this is partial negative charge. Here what means this is showing plus I effect, this is showing plus I effect. Two R groups are showing plus I effect. Therefore, this carbon is getting electron cloud from both sides. Therefore, here electrophilic center, electrophilic nature will be less. So, nucleophile attacking less easily here. Therefore, it is going for nucleophilic addition less tendency. Therefore, aldehyde will have higher nucleophilic addition tendency than ketone. Okay, out of aldehyde and ketone, which is having higher nucleophilic addition tendency means aldehyde is having higher tendency than ketone. Okay, then we will take a aromatic ketone. We will take. Now we will take a aromatic ketone. Okay, here already we said aliphatic ketone. We said now we will take aromatic ketone. So aromatic ketone in the sense how it will be there, that we will see. Aromatic ketone in the sense like this aromatic ketone. What will happen in the sense here pi electron cloud will be there in the phenyl ring. In the phenyl ring pi electron cloud is there. Therefore, what is possible in the sense of resonance? Resonance is possible like this. Therefore, here electrophilic nature is less. Therefore, nucleophile will add with a less tendency here. Less tendency. Therefore, aliphatic ketone is having higher tendency of nucleophilic addition. Aliphatic ketone is having higher tendency of nucleophilic addition than aromatic ketone. Then we will take what in the sense acid halide we will take. Acid halide. This acid halide, how the nucleophilic addition tendency will be there, we'll see. Acid halide in the sense RCOCl, for example. Here what happens when Cl is having 3 lone pairs. So here resonance is possible like this. Due to resonance, here positive charge will be less. This R group shows plus I effect, therefore positive charge will be less. Therefore here nucleophile adding less tendency, therefore nucleophilic addition will be low here. So ketone is having higher nucleophilic addition than acid halide. So out of acid halide and ketone, which is having higher nucleophilic addition in the sense ketone is having higher nucleophilic addition. Okay. So first one is what in the sense aldehyde. Aldehyde is having higher tendency of nucleophilic addition than ketone. Then ketone is having higher tendency than acid halide. In the acid halide, we will take what in the sense RCOCl, RCOBr, RCOI. We will take how the nucleophilic addition will be there in this case. We will see. RCOCl, RCOBr, RCOI. How the nucleophilic addition will be there here, that point we will see. Now RCOCl, RCOCl we have taken and RCOBr we have taken, RCOBr. Okay. So how the nucleophilic addition tendency will be there. Okay. This is showing resonance like this. It is also showing resonance like this. But here 3p orbitals involved, here 4p orbitals involved. So that here overlapping tendency will be more, overlapping tendency will be more, overlapping tendency will be less. Therefore, resonance will be more effective, resonance will be less effective. Resonance is more effective means this carbon electrophilic center, electrophilic nature will become less. Electrophilic nature becomes less in the sense nucleophilic addition will be less. Nucleophilic addition will be more. Okay. Therefore, in RCOCl, nucleophilic addition will be less. RCOBr is high. RCOBr is less when compared to RCOI. Okay. Then acid halide and acid anhydride we will compare. Acid halide and acid anhydride let us compare. Okay. Which is having higher nucleophilicity? It is acid halide. Now acid anhydride will take. Acid anhydride. Acid anhydride. Here what happens means it shows resonance. Here resonance is possible like this. Here also resonance, here also resonance. But what is the drawback in the sense this is electron withdrawing group. It is electron withdrawing group. Therefore, here resonance tendency will be less. It is electron withdrawing group. Therefore, here resonance tendency will be less when compared to this. So here resonance tendency, resonance tendency. If you see that where it is less in the sense resonance tendency will be less here, resonance tendency will be more here. Therefore, what happens means electrophilic nature will be less when compared to this. So nucleophilic addition will be less here when compared to this. Okay. So what experimental evidence says that acid halide is having greater nucleophilic addition than acid anhydride. It is given. Acid halide, acid halide is having greater nucleophilic addition than acid anhydride. So how to explain this? That we will see. Now we cannot use this this electron withdrawing group nature we cannot use, which is having higher which is having higher nucleophilic addition tendency means this when compared to this. So what shall we do? Now we have to think in another way. Here, what is leaving in the sense Cl minus is leaving during nucleophilic addition. Here, what is leaving in the sense Cl minus is leaving. In the acid anhydride, what is leaving group? What is leaving group in the sense it is a leaving group. That means RCOO minus leaving group. It is very weak base, but it is weak base. Therefore, which is having good leaving tendency in the sense Cl minus is having good leaving tendency when compared to this. It is leaving easily, therefore it is undergoing nucleophilic addition easily when compared to this. Therefore, it is having higher nucleophilic addition tendency when compared to this one. Okay. Next ester will take. Ester and acid anhydride. Okay. Ester and acid anhydride we are taking. So acid anhydride will take like this. Acid anhydride. Ester will take like this. Ester we are taking like this. So in both cases, resonance is possible. Okay. Here, if you see resonance is there. Here, if you see resonance is there. In both cases, resonance is there. It shows plus a effect. Therefore, resonance will be more here. It is electron withdrawing group. Resonance will be less. Therefore, resonance will be less in the sense here electrophilic nature will be more, so nucleophilic addition will be more when compared to this. Okay. Therefore, which is having higher nucleophilic addition means acid anhydride is having more than ester. Then we will take amide. Then we are taking what in the sense amide we are taking RCONH2. RCONH2 will take. Okay. So it is going for resonance. This here electronegativity of nitrogen is low, electronegativity of oxygen is more. So resonance is more here, therefore electrophilic nature will be less, electrophilic nature will be more. Electrophilic nature is more in the sense nucleophilic addition will be more tendency here. So nucleophilic addition will be more tendency here. Okay. Next acid. Next acid we can say that means carboxylic acid. Next carboxylate anion. Carboxylic acid, carboxylate anion we can say. It is the order of reactivity towards nucleophilic addition. It is the order of reactivity towards nucleophilic addition we can say. So what is the order of reactivity towards nucleophilic addition in the sense like this we said. Okay. Next we will go for nucleophilic addition followed by loss of water. Okay, that we'll see with ammonia derivatives. We'll see nucleophilic addition followed by loss of water, that we are seeing with ammonia derivatives. Now we will take carbonyl compound. Will take ammonia derivative. We will take ammonia derivative. We are taking, that is ammonia means NH3 instead of 1H. Some other group we will add here. We are keeping optimum pH. Optimum pH how much in the sense 3 to 4. So what we are getting in the sense so and so we are getting, so and so product we are getting. Sir, now how do we say this is nucleophilic addition followed by loss of water? That we will see. Okay, sir. So now we will see the mechanism. We'll see the mechanism. This carbonyl group we will take. Carbonyl group first H plus is adding over this oxygen. Okay, so H plus is attacking. Therefore we are getting what in the sense here OH, oxygen is having one lone pair and positive charge is there. Now next point is what in the sense a nucleophile is adding this nucleophile. This nucleophile comes for attack. This nucleophile is having NH2 and G. N is having lone pair. N is having lone pair. It is attacking this carbon. This pi bond is shifting here. Therefore, we are getting what in the sense here NH2, here NH2G, NH2G, single bond OH. single bond OH we got. Okay, sir. What is the next step? We will see. What is the next step? That step we'll see. N is having positive charge here, so that what happens means this bond is becoming lone pair, and this H plus is going to this place, so that we will get here NH NHG. N will have one lone pair will have here this H2O, this oxygen will have positive charge. Oxygen will have positive charge. Okay. So next step, what happens in the sense? What is the next step here? That we will see. What is the next step in the sense? This bond pair is becoming pi bond. This is leaving. Okay. So H plus is leaving from here. Water is leaving from here. Therefore, what we are getting in the sense C double bond Ng we are getting. Okay. So we are getting like this. Now, why it is called a nucleophilic addition? Okay, here C double bond O is there. This becomes what in the sense? This double bond becomes single bond. Here C double bond O. This double bond becomes single bond here. Okay, here H plus is adding first. Here H plus is adding first. That H plus is removed here. Here H plus is adding, H plus is removed. Okay, so leave about this H plus. Okay, we will cancel this H plus. Here nucleophile is adding. Nucleophile is adding. Okay, therefore it is nucleophilic addition reaction. Here what is removed here? Water is removed. Therefore loss of water. Okay, so nucleophilic addition followed by loss of water we said. Okay. Then this carbonyl compound, this nucleophile is adding this carbonyl compound after H plus is after the H plus adding here. If H plus is adding to this oxygen, we are getting this positive charge. Then nucleophile is easily adding. Nucleophile is easily adding. Therefore, this nucleophilic addition is possible if H plus is adding into oxygen and making oxygen to get positive charge. Then only nucleophile can add into this carbon. Therefore, we have to keep pH in acidic medium pH we have to keep. So we have to provide some acidic medium we have to provide. Sir, that so acidic medium in the sense, what is the pH provided in the sense 3 to 4 pH is provided. Why should we provide 3 to 4? Why can't we less? 3 to 4 in the sense acidic medium only, because pH is less than 7 means acidic medium, no doubt, at 25 degrees Celsius. Why can't we provide pH 1 or pH 2? Because pH 1 or 2 in the sense acidic medium will be more. If acidic medium is more, what happens means this ammonia derivative will go for acid-base reaction. What is that acid-base reaction? That we will see. We will take this ammonia derivative. Okay. If acidic medium is more, that means pH is 1 or 2. What will happen means it will combine with H plus. Then it gives what in the sense? It gives also salt. It gives. Now this salt, in this salt, nitrogen is not having lone pair, therefore it will not go for nucleophilic addition with the carbonyl compound. So that if we keep strong acidic medium, pH 1 to 2 like this, if we keep, then this nucleophile will lose its nucleophilicity by reacting with this acid and forming salt. Therefore, we should not keep acidic medium. Too strong acidic medium we should not keep. Highly acidic medium we should not keep. Therefore, optimum pH what in the sense 3 to 4. We want acidic medium, but acidic medium should not be highly acidic. Therefore, we are keeping optimum pH how much in the sense 3 to 4 optimum pH we kept. Okay. Now, in the place of G, what can we take? That we'll see. Okay. 1. So, in the place of G, what we can take? That we'll see. Okay. First, we will write this equation. So, what is that equation in the sense? So, one is carbonyl compound, then ammonia derivative. So, optimum pH what in the sense 3 to 4, optimum pH 3 to 4. Then what we are getting in the sense C double bond N OH. Here, we have to take G, we have to take ammonia derivative in the sense, ammonia derivative formula here G only, no, G plus water. Okay. Now, in the place of G, what we are taking means OH group we are taking. In the place of G, we are taking OH group. Okay. So in the place of G, what we are taking in the sense OH group we are taking. Okay, OH group we take. So if we take OH group, then it is called what in the sense oxime we can say. Oxime. C double bond NOH is called oxime. In the place of carbonyl compound, if we take acetaldehyde, what will be there means here CH3, here H will be there. So you give here CH3 and H, here CH3 and H. This is called acetaldehyde is there. No, in the acetaldehyde, you take this part. In the acetaldehyde, you are taking this part, then you are including this oxime. Okay. If you take acetone, what product will get? We'll see. Acetone you are getting in taking in the sense acetone with this hydroxylamine. It is called what in the sense hydroxylamine. It is called hydroxylamine. Optimum pH how much we are keeping in the sense 3 to 4. So what product we are getting in the sense CH3, C double bond NOH we are getting plus O2. Okay, it is called acet oxime. In the acetone, it is from acetone. So in the acetone you take this and include oxime. Acet oxime we are getting. Okay, so we got what in the sense acet oxime. So carbonyl compound reacting with ammonia derivative, what is that means hydroxyl amine gives what in the sense acetal dioxide and acetoxime. Okay. Next we will take we will change the ammonia derivative. We will change now. So what is the ammonia derivative we are taking now? Okay, ammonia derivative is this one. What is that means hydrazine. So in the place of G, what we are taking? In the place of G, we are taking NH2. Okay, we have taken hydrazine. So what we have taken in the sense hydrazine. So that now what is the compound we will get? That we will see. So here NH2, here also NH2. Okay, so like this compound we got. So what is the name of this compound? This compound is called hydrazone. This compound is called hydrazone. So in the acetaldehyde, this is from acetaldehyde, take acetal. This is from acetone, take acet. Then what we have to include in the sense, we have to include hydrazone, we have to include acetaldehyde, acetald hydrazone. That means we have to say full name, we have to say here. That full name in the sense acetaldehyde name, we have to say full name. So acetaldehyde full name we are saying, here also acetone full name we are saying. Then hydrazone alone we are including, hydrazone included. So hydrazone we are including, okay, acetone hydrazone it is a acetaldehyde hydrazone. Okay, next we will change the G. Now we will change the G as what in the sense so and so. G is so and so. Okay, so we have changed the G. So this G is what in the sense now so and so. This is called what in the sense phenyl hydrazine. This is called phenyl hydrazine we can say. Okay, so we have taken phenyl hydrazine. So how it will be there? What is the name of this one? That we will see. Now, so here also that phenyl ring we will give. Here also phenyl ring we have given. What is the name of this one in the sense? This is called phenyl hydrazone. Phenyl hydrazone. So acetaldehyde phenyl hydrazone we can say. Acetaldehyde phenyl hydrazone. This we can say acetone phenyl hydrazone. Acetone phenyl hydrazone we can say. Okay. So next we will change the G now. G is what in the sense here one NO2 group, here one NO2 group. Okay. G is this one. Two NO2 groups we have written. So here one NO2 group, here one NO2 group. What is the name of this one means 2,4 dinitro phenyl hydrazine. 2,4 dinitro phenyl hydrazine. So here one NO2, here NO2. Okay. So here one NO2 group, here one NO2 group. This is called 2,4 dinitro phenyl hydrazone. 2,4 dinitro phenyl hydrazone we can say. Okay. 2,4 dinitro phenyl hydrazone. So what is the name of this one means acetaldehyde 2,4 dinitro dinitrophenyl hydrazone, 2,4 dinitrophenyl hydrazone. Here also acetone, 2,4 dinitrophenyl hydrazone. Okay, it is the name of this one. Okay. Next, we will change the G. We will change the G now. G is what we will see. Now we will change the G. G is what in the sense CONH2. Okay, CONH2. This is we have changed the G. Okay, now we will change G. We will change. So G is what in the sense so and so. G is so and so. This name is what in the sense semi-carbazide. This is what in the sense semi-carbazide. Semi-carbazide. Okay. So now we will change the G. So we'll change the G. So what is G in the sense CONH2? Okay, that means NHCONH2. Okay, so this is what in the sense semi-carbazone. Semi-carbazone. So acetaldehyde semi-carbazone. Acetaldehyde semi-carbazone. Acetaldehyde semi-carbazone. Here also we will change. So here also we are changing. So here NHCO NH2. It is acetone semi-carbazone. Acetone semi-carbazone. Okay, sir. In this semi-carbazide, which is nucleophilic center, here nitrogen is having lone pair. Here nitrogen is having lone pair. Here nitrogen is having lone pair. Which is better nucleophilic center means this N is the better nucleophilic center. Why? Because this CO group is electron withdrawing group. Electron withdrawing group is neighbor to this N, neighbor to this N. This electron withdrawing group is far away from this N. Therefore, this N is better nucleophile when compared to these two N's. Okay, sir. This is about reaction with ammonia derivatives. Sir, carbonyl compounds reacting with ammonia derivatives like this. Okay. Next, we will say carbonyl compounds reacting with ammonia. That we will see. Okay. Now we will take acetaldehyde. We are taking acetaldehyde that is reacting with what in the sense ammonia. How the reaction will be there, that we'll see. Here what in the sense this nitrogen is having lone pair, this lone pair is attacking this bond pair is migrating to oxygen. So what we will get CH3, CH, this O minus, and here NH3 plus. NH3 plus nitrogen is having positive charge. Next, what happens means this bond is becoming lone pair and H plus is going towards this oxygen. So we are getting CH3, CH, this OH, this oxygen is having two lone pairs, and here NH2 is there. NH2 is there, nitrogen is having lone pair. This name is called what in the sense acetaldehyde ammonia. This name is called acetaldehyde ammonia, we can say. Acetaldehyde ammonia. This on warming, what happens means water molecule is leaving. Sir, how the water molecule is leaving, that we'll see. Okay, here water molecule is leaving. This bond is shifting here, this bond is shifting here. Therefore, we are getting CH3, single bond CH, double bond NH. Like this compound we are getting. From acetaldehyde, we will take this part alone. This part alone will take acetald. Acetald will take, and we will include what is this group in the sense it is called imine. It is called imine. Acetaldimine we are getting. Okay, so we got what in the sense acetaldimine we got. So acetaldehyde with ammonia we are getting, acetaldimine we are getting. Then acetone with ammonia, what we will get? Acetone with ammonia, what we will get, that we will see. Okay, so acetone with ammonia, that point we will see. Acetone with ammonia, that means instead of this hydrogen, what we are taking in the sense CH3 we are taking. Okay, so instead of this hydrogen we are taking CH3. Now it is acetone. Here also CH3, it is acetone. Here also CH3, it is acetone. Next step what happens means not like this. Next step is not like this. What is happening means it is reacting with another acetone molecule, that is reacting with another acetone molecule. Okay, so another acetone molecule we are taking. So another acetone molecule will take like this. Okay, another acetone molecule. So another acetone molecule will take in some difference, will some other manner will take in how in the sense another acetone we are taking like this. Another acetone we are taken like this. So what is the reaction takes place here? What is the reaction takes place here means like this reaction is possible. Okay, therefore we are getting a CH3, CH3, NH2, CH2, CO, CH3. Like this we are getting. So this compound we got by the reaction of two acetone molecules, therefore diacetone will take diacetone. This compound we got by the reaction of two acetone molecules and one ammonia, therefore diacetone ammonia. This name is what in the sense diacetone ammonia we are saying. Okay, so acetone with ammonia, like this reaction possible. Next, we'll take some aldehyde, we'll take some aldehyde, then aliphatic amine we'll take. Okay, we are taking aliphatic amine. We are taking what in the sense aliphatic amine we have taken. So we have taken aliphatic amine, then aldehyde. So what is the reaction is possible here, that we will see. Now this lone pair is attacking this carbon, this pi bond is migrating to oxygen. So what is the product we are getting in the sense? Here O minus, this O minus oxygen is having 3 lone pairs. Here hydrogen, here N, R dash, H, H, this is having positive charge. Okay, nitrogen is having positive charge. This bond pair is shifting, this H plus is going to oxygen. So we will get RC, OH, oxygen is having 2 lone pairs, H, then NHR, NHR. Nitrogen is having lone pair. Nitrogen is having 1 lone pair, we can say. What is happening next step? What is the next step in the sense? Next step is this bond is migrating here. This bond is migrating here. So this H plus and OH minus becomes water, that is removed. So what we are getting means RCH double bond N lone pair R dash. Okay, we are getting a what in the sense so compound. This is called a Schiff's base. It is called a Schiff's base. We can say this compound is called Schiff's base. So Schiff's base is obtained by the reaction of what in the sense aldehyde with aliphatic amine. Aldehyde reacting with instead of aliphatic amine, instead of saying aliphatic amine, we can say better primary amine, we can say, because we can take even aromatic amine also we can take. So primary amine we are taking. So primary amine, aldehyde with the primary amine gives what in the sense Schiff's base. Now this aldehyde, I will take benzaldehyde, I will take. Aldehyde in the place, benzaldehyde I will take. This primary amine in the place, this primary amine in the place, aniline I will take. Aniline I am taking. So what is the product in the sense? In this R, in the place of R, C6H5. Okay, C6H5. Remaining thing will write CH double bond N will write. Okay, CH double bond N. CH double bond N. In the place of R dash, C6H5 is there. That C6H5 will write. Okay, so this is called what in the sense? This name is what in the sense? Benzol, benzol, benzol aniline, benzol aniline. Why benzol aniline? We'll see. This name is aniline. This name is benzaldehyde. This name is what in the sense benzaldehyde. So you are taking benzol, benzol aniline. You are saying benzol aniline. Therefore, this aldehyde is even aromatic also we can take. Aromatic or aliphatic. This amine means primary amines. Aromatic amine also we can take. Okay, sir. Now we will see next reaction. We'll see carbonyl compound reacting with what in the sense PCl5. That reaction we'll see. Now acetaldehyde we are taking acetaldehyde with the PCl5. With the PCl5, what is the reaction? We'll see. So what is happening in this one in the sense this bond acetaldehyde. This bond is this Both bonds are breaking. 2Cl here and PCl3 here. Okay, sorry, PCl3 with oxygen we have to give. PCl3 with oxygen we have to give. So that here PCl3 we have to give, here two chlorines we have to give, two chlorines, because two bonds are breaking. Okay, two bonds are breaking, therefore two chlorines we have to give. Therefore, what is the product in the sense CH3 CH? Two chlorines we have to give to this carbon because two bonds we are breaking. PCl3 takes oxygen and becomes POCl3. Here, if we see two chlorines adding to same carbon, therefore it is called gem dihalide. We can say gem dihalide. Now we will take acetone. We are taking acetone with PCl5. Acetone with PCl5. What is the product? We will see. Here, what we can do means here one bond will break, one Cl will give. Another bond will break, another Cl. For oxygen, you give PCl3. Okay. For oxygen, you are giving PCl3. So what we are getting in the sense CH3, CCl, okay, CH3. This carbon is having two chlorines because here two bonds are breaking. Okay, therefore it is a gem dihalide, we can say. PCl3 takes oxygen and becomes POCl3. PCl3 is taking oxygen. This PCl3 is taking oxygen and becomes POCl3, we can say. Next, we will see test for a carbonyl compounds. We will see aldehyde and ketone test. We will see one test is called what in the sense tolerance test. One test is called a tolerance test. We will take. So, how to prepare tolerance reagent? What is tolerance reagent? How to prepare that? We will see. To prepare tolerance reagent, we are taking ammonium hydroxide and silver nitrate solution. Silver nitrate solution. What happens means this Ag plus takes this OH minus and becomes what in the sense AgOH. AgOH is precipitate. This NH4 plus takes this NO3 minus and gives NH4NO3 solution. It goes to solution. So we got what in the sense AgOH precipitate. We got to this precipitate. You add still more amount of ammonium hydroxide and shake. This AgOH precipitate with still more amount of ammonium hydroxide. Still more amount of ammonium hydroxide. What happens means the precipitate dissolves. Why the precipitate dissolves in the sense due to formation of complex. What is the complex in the sense AgNH3 twice OH minus. Okay, AgNH3 twice OH minus and water molecules obtained. This is called tolerance reagent. So how this tolerance reagent is obtained? By the reaction of AgOH with ammonium hydroxide, that we will see. Okay, so now we will take AgOH as a Ag plus OH minus. Will take ammonium hydroxide. Will take it as a ammonium ion. Ammonium ion is NH4 plus OH minus ammonium ion. Ammonium ion we are taking how many times means two times. We will take two times ammonium hydroxide we are taking. Okay, so what happens? What is the reaction possible here? That we will see here. What is the reaction means this OH minus takes H plus and becomes water. This pi bond shifting to here as lone pair. In the same manner, H plus taking OH minus and becomes water. This sigma bond shifting to nitrogen as lone pair. Then this is ammonia. This is ammonia. This nitrogen is coordinating with the Ag plus. This nitrogen also coordinating with the Ag plus. Okay. So this Ag plus we have written and two NH3 groups we have written and this OH minus we have written two water molecules. This is called tolerance reagent. So how to define tolerance reagent in the sense? How to define this tolerance reagent? Here for preparing tolerance reagent we are taking ammonium hydroxide. Therefore we are saying ammonical. Ammonical we are saying. Then we are taking silver nitrate. Silver nitrate we are taking. Therefore we are saying silver nitrate. Silver nitrate solution. This is called tolerance reagent. Ammonical. Why? Because we are taking ammonium hydroxide. Silver nitrate because we are taking silver nitrate. Ammonical silver nitrate solution is called tolerance reagent, we can say. What is the formula of tolerance reagent in the sense AgNH3 twice outside OH minus. Here plus will be there, here minus will be there. Therefore, tolerance reagent is AgNH3 twice plus. Tolerance reagent is what means AgNH3 twice plus. Okay, like that we can say. Now AgNH3 twice plus is a complex ion. Tolerance reagent is what? AgNH3 twice OH. Okay, how we can write this one in the sense AgNH3 twice plus in aqueous solution.